Hello, welcome to this AWS webinar. My name is Ian Massingham. I'm a technical evangelist with Amazon Web Services based here in Europe, and I'm going to be your host for this session today. It's a Journey Through the Cloud series webinar today, and we're focusing on security best practices on AWS. We do have another series of webinars which you might be interested in. It's called the Masterclass series, and it focuses on specific AWS services, taking a deeper dive into the features and functionality of those services and explaining how you can use those in some more advanced use cases and more advanced scenarios. But we're on the journey through the cloud today, so we're focusing on a particular solutions area rather than one specific AWS service. And the objective of this particular webinar is going to be to guide you through common use cases for operating secure environments on AWS, help you learn from some of the experience we've developed in working with other customers, and give you some best practices clearly within this webinar today to help you bootstrap your projects on AWS in a more secure fashion. In the webinar interface, you can see a few things. At the top, you can see a Q&A panel. If you do have questions during the session today, please submit those via that Q&A panel, and we'll get back to you in due course with answers. Even if we don't have time to come to your questions during the session today, we have a solutions architecture team who will follow up with you on any questions that you've got, send you a note with an answer and also with some useful references. The other things that you can see in the webinar interface are a links panel, which will be populated with a few useful links that you might want to follow that relate to what we're going to show you today in the session. Also useful social media accounts that we might talk about towards the end of the session today. And lastly, a materials download panel. So if you want to grab the slides from today's session in PDF format for your reference or to share with any colleagues, then you can get those from the materials download right now. After the session today, we will also post a recording of this webinar on the AWS Webinars YouTube channel, and we'll make that available to you on the AWS UKI Twitter, and also send that out to you in a follow-up email. So if you want to rewatch any areas of the webinar today or share that recording with colleagues, you're obviously more than welcome. We'd encourage you to do that. Lastly, when we finish up the webinar, we will switch into Q&A mode to have a look at some questions that you might have submitted during the session today. And during that period of Q&A, you'll be able to rate the session. Give us a score from 1 to 5 if you would, please. It's really helpful for us in optimizing the webinar program for future customers, future partners that might attend. And also, if you want to provide any qualitative feedback, please feel free to do that using the Q&A interface. We'd love to know what you think of the session today. If you think there are problems, sections of the webinar that we haven't focused on enough, or you think there are any problems with the delivery, then please let us know, and that'll again help us optimize delivery of these webinars for future customers. So what are we going to be talking about today? Well, we're talking about security best practices on AWS today. And what we're trying to illustrate to you during the session today is that the AWS cloud has been architected to be one of the most flexible and secure environments that you can use. Okay, we're trying to show to you that we're removing many of the security headaches that come with operating your own infrastructure, and also demonstrate that the way the architecture is built and the tools that we provide you with enable you to ensure complete privacy and segregation of your data and workloads. And there are many built-in security features in the AWS cloud that can help you achieve that. And the agenda that we're going to follow to do this today, first of all, we're going to take a quick tour through the shared security responsibility model on AWS. Then we're going to look at AWS security features in overview. We'll then come to the best practices, the core part of the session today, 10 best practices that you can use to assure the security of your workloads on AWS. We'll talk briefly about verifying our security with our compliance statements and how you can access those compliance statements. And then, as usual, we will finish up with some useful resources that you can make use of if you want to learn more about the topic area that we're going to cover in today's session. Before we do any of that, though, let's just say, first of all, that security is our number one priority here at AWS. We have very comprehensive security capabilities that we've built into the services that we provide and also into the platform that underlies those services. And that should give you confidence that you can use the AWS cloud as a location within which you're going to run high security, high privacy or high compliance workloads. And this has been validated by security experts from a number of the world's leading organizations. So you can see a collection of logos there on the left-hand side of this slide. Every single one of those customers has been through an extensive security due diligence exercise together with AWS. and they have validated the platform and processes that AWS use to manage that platform. And today they're all running compliant and secure workloads inside the AWS cloud. So that should give you some confidence that some of the world's leading organizations have taken a very good look at AWS's security infrastructure and practices and have a level of confidence in that. We also work with customers like these on enhancing our security practices and the security features of our services. So actually, if you're using AWS and you feel there's something that we can do to improve the security of our services, or there's a security related feature that you would like to see in the AWS cloud, please let us know about that. Please reach out to us via the Contact Us or via the Contact Us form or via your account manager. And let us know if you think we can do better, and we can work on that together and make sure that every customer benefits from the stretching requirements that we get from some of our leading customers. That's the great thing about the cloud, really. We have a very standardized, highly automated platform that we make available for you to use to run your applications, workloads, and services. And if we enhance that platform, then every customer benefits from that. It's a kind of highest common denominator principle and practice, essentially. So security features that are recommended by these leading customers are then rolled into the platform and made available for every other customer to benefit from. And we use the same kind of familiar controls in physical security, network security, platform security, and in people and procedures that you will use within your organization. So don't be afraid about putting high security, high compliance workloads in the AWS cloud. Many people do it, and it's a very safe place to run those kind of workloads. The first section that we're going to talk about on the agenda is sharing the security responsibility. And this is something that AWS are very clear about with our customers and prospective customers. So it's very important to be aware of the fact that you, as customers of AWS, have your own responsibilities in securing your services. So it's definitely a shared responsibility. We will do the heavy lifting of securing the facilities from a physical perspective and operating them, of securing the physical and network infrastructure and the virtualization infrastructure, and then securing the hardware that we provide. But conversely, you as a customer have your own responsibilities to choose and secure a guest operating environment, to configure your application in a way which meets your security needs, to configure your AWS accounts and your security groups, ACLs, and the other platform features that we provide, such as identity management, in a way which will help you create and maintain your security posture. So it's important to understand what that DMARC is. And to help you understand that, we're going to take a quick tour through three different service models that AWS supports and make it clear where the DMARC is in each of those different options. So the first is infrastructure services, and you can see here that we are managing the AWS Global Infrastructure and Foundation Services, or managing the security of the AWS Global Infrastructure and Foundation Services. We're providing IAM and those AWS endpoints, but beyond that, we're placing a set of tools into your hands that enable you to, as I've said, implement and maintain a security posture that meets your needs. So you have to use those tools in a way which ensures that you do that. And it's very important, obviously, to be familiar with those tools. And that's part of what we're going to talk about later in the session today. So this is for infrastructure-centric services such as Amazon EC2, Amazon EBS, Amazon VPC, and others. Beyond that, if we're getting into container services, so these are services where AWS manages the underlying infrastructure and the foundation services, but also the operating system and the application platform. So examples of this will be things like Amazon RDS, where, if that's an Oracle RDS instance, we're managing all layers of the container up to and including the Oracle database platform. So we're providing data backup and recovery, but it's your responsibility to configure and use those tools in relation to your business continuity and DR policies. So a higher level of tooling is provided, but there are still obligations that fall upon your shoulders as a customer in terms of how you manage and configure those platform containers. And then lastly, on abstracted services. So this would include things like Amazon S3 or Amazon DynamoDB, where we're operating the infrastructure layer, operating systems and platforms, as we were on that previous slide. And you use endpoints to store and retrieve data from these services. And in this particular example, these services are tightly integrated with our identity and access management service, something that you're going to hear a whole lot more about later in today's session. So you, in these scenarios, will be responsible for managing your data using IAM and the associated tools to apply ACL type permissions to those individual resources at platform level. Okay, and we'll talk a little bit more about that later on in the session today. So once again, we're providing you with a set of tools which extends further up the platform in this third scenario of abstracted services. But you need to use those tools in the right way in order to ensure that your security posture, as we've said, is implemented and maintained over time. Let's move on now and take a look at some foundational security features that are inherent within the AWS cloud and talk briefly about how these contribute towards your ability to develop those security postures. So the first is secure access. This is quite obvious. Customer access points, you might call them API endpoints, that allow you access to AWS services. Well, they're encrypted using SSL. And obviously that encryption ensures the privacy and also the integrity of communications with those endpoints. That's a foundational component of the services that we provide. Another is built-in firewalls. We call these security groups. So these are the software firewall rules that you place around your EC2 instances and actually other services such as, for example, RDS instances or EMR clusters that you might create. And they permit or deny traffic to and from your instance-based resources. Okay, and if you're inside a VPC, something again which we'll talk about later in the session today, you can also control outbound traffic or egress traffic as well as that ingress traffic. So there's powerful built-in firewalls that you can use to allow or deny traffic to and from your instances. You can also create and maintain unique users with specific access levels to your AWS account. So this relates to the use of our Identity and Access Management Service, IAM, and it enables you to have unique users with unique security credentials and a unique set of permissions for each user that you might create, or you may place users in a group where they share a set of permissions for specific resources. And this allows you to implement security best practices of role separation and also least privilege. And you use these typically for logging into the AWS console to create, change or destroy services, or to call the AWS APIs. So a very powerful feature, but you can, as we've said, create unique users with their own specific privilege levels. Multi-factor authentication is built in, so this is for use at the root account level within your AWS account, or for use with individual IAM user accounts that you might create. And you can use a variety of multi-factor tokens, whether that's soft tokens such as the Google Authenticator or the Amazon Authenticator, or hard tokens. We support a couple of different hard tokens as well. So if you want to make use of multi-factor authentication, we would recommend that you do. That is built into the AWS platform for you to take advantage of. The AWS VPC service, Virtual Private Cloud, allows you to add another layer of network security to your instances by creating private subnets. And within these private subnets, you can restrict access using network ACLs to prevent access from other subnets, even within your own VPC, within your own virtual private cloud. And you can create tunnels to and from these private subnets, for example, IPsec VPN tunnels to your home network. So connect your network to your AWS VPC into a private network, and to do so once again in a way which ensures the privacy and integrity of traffic going to and from that subnet. So you're able to build secure zones, something again which we'll talk about later in today's session, within your Amazon VPC that you may use for hosting workloads with particular security or compliance requirements. There are also many features for data encryption within AWS. So you can have the data and objects you store in services like Amazon S3, Glacier, Redshift, Oracle RDS, encrypted automatically using advanced encryption standard AES 256 keys. So it's a very, very secure symmetric key encryption standard, and you can apply that to much of the data that you store in AWS. And once again, we will talk about that in some detail later in today's session. You can also build dedicated connections into your AWS cloud. So this is using a service called AWS Direct Connect, where you are using a private, high bandwidth, low latency network connection between your data center or network and an AWS region, and you can partition that into multiple logical connections using 802.1q VLAN standards. And this enables you to access both public and private IP environments within your AWS cloud from your own network in a secure way. And of course, if you wish to, you can encrypt traffic that is transiting across that direct connect link using IPsec to further ensure the privacy and integrity of that data. But you're essentially taking your traffic off the internet when you make use of direct connect, which again may be required for certain compliance standards. Security logging. We have a service called AWS CloudTrail. It provides logs of all user activity within your AWS account by logging API calls to AWS services, and you can see what actions were performed on each of your AWS resources, when and by whom. Again, we'll talk about that further, but there's security logging built into the service at the foundational level. We have an isolated region in the US, which is applicable for US government workloads or for workloads that are sponsored by US government users. And this is, for example, for compliance with US ITAR regulations, or to make use of special endpoints that are FIPS 140-2 compliant, so high levels of encryption. This is important for US federal government use. We also have a service called the Cloud HSM. So this is a highly secure way to store encryption keys within AWS using hardware security module appliances for cryptographic key storage. So store your keys in a tamper-proof hardware device in the AWS cloud and use those keys to encrypt and decrypt data as you need. Provides a highly secure and convenient way for you to store and manage encryption keys. And then lastly, on platform features, Trusted Advisor. This is pretty cool. This is a customized expert system, essentially, that will take a look at your AWS environment, your resources, and it will alert you to potential areas of non-compliance with security best practices. So if you've got, for example, overly permissive access to certain EC2 instance ports or S3 storage buckets, or you don't have sufficient role segregation within your IAM account, or you have weak password policies within your IAM user base, it will warn you about that automatically and encourage you to make the changes that are required to bring you back in line with best practices. So a very powerful tool available to all customers that make use of AWS Business Support. And you can find details about that at aws.amazon.com/premium support. So those are some platform features. Let's move on now and talk about the application of those platform features in the form of these 10 best practice areas that we're going to focus on. So best practices for securing your AWS environment. First is to know that shared security responsibility model that we talked about earlier. So regardless of which model you are using, whether that's infrastructure, platform, or abstracted services, be cognizant, be aware of where AWS's responsibility stops and your responsibility starts. Okay, and make sure that you are securing on both sides of that line by using the tools that AWS provides to secure the areas that are in your scope. Okay, and we're going to talk about many of those features in this section, but use those features that you've just heard about in your scope area, and we're going to talk about how to apply them to ensure that your scope area is secured in accordance with whatever information security management system you put in place and whatever compliance or regulatory requirements you're working with. Second area to be aware of is the AWS Secure Global Infrastructure. So be aware of how regions and availability zones are used to construct that infrastructure. If you have location-dependent privacy or compliance requirements, you can make use of AWS regions to fulfill those requirements. So for example, if you need to store your data inside the European Union, place your data in the EU West 1 region in Ireland, and your data will be stored within the European Union. You can then use availability zones within that single region, so physically separate facilities in those availability zones, to make sure that you're designing for the right level of availability and failure tolerance for your app without having to move your information outside of that specific region. So that can be really helpful. You can also, of course, use these regions to optimize for performance by minimizing user latency when the users are accessing your applications. So that can be really helpful as well. And of course, make use of those availability zones, as I've said, to design your applications for availability. Availability being a core component of application security, of course. Similarly, on global infrastructure, IAM is a global service, and this is something that is fundamental to securing your AWS account and the resources that are represented within that account. So something that it's very useful to become familiar with. With IAM, you can centrally manage users' security credentials, such as passwords, access keys, and permissions policies that control which AWS services and resources individual users can access. So it's a very powerful tool that you can use to restrict or allow access to specific AWS services, and we'll talk more about this as we get later through this best practices session. What we won't talk about again is MFA. We've already briefly mentioned this, but it's a very, very good idea to use multi-factor authentication to protect your root account and to protect individual least privileged accounts also, and you can allocate different multi-factor authentication tokens and therefore different secrets to different users within your account. So I may have one authenticator and you may have another, and we may fulfill different roles within the AWS management scope for a particular organization. There's much more information about IAM best practices that you can access if you follow the link at the bottom of the screen there, but I really would encourage you to familiarize yourself with IAM. It's a very powerful tool and one that many AWS users use to great effect to enhance the security of the environments that they're using within the AWS cloud. So take a look and familiarize yourself with IAM. In common with any IT deployment, really, it's important to define and categorize the information assets that you're going to be storing or processing within the AWS cloud. So before you start, you want to spend some time identifying the information assets that you need to protect, okay, and designing a technically and financially viable solution for protecting those assets. Sometimes it can be quite hard to quantify every asset in very specific financial terms, so you may find that using qualitative metrics like negligible, low, medium, high, very high could be a better option, but it's important to classify and understand what the assets are that you're going to be, as I've said, storing and potentially processing inside the AWS cloud. And these assets are likely to fall into two categories: essential elements, which are the if you like, the objects that your environment is going to work with, business information, processes and activities that may be handled by the resources that you're going to deploy in AWS. And then you may have components that underlie that, such as hardware, software, personnel, sites and partner organizations. So you want to have a look at assets in both of those categories and make sure that you fully understand the landscape that you're working with before you start with the next part, which is designing an information security management system that will protect those assets. So establish a standard for essentially implementing and operating that security management system, which is going to protect those assets in accordance with their value. And you may find that security requirements will differ in your organization from others, depending on your particular business needs and objectives, what your processes are, and also what the size and structure of your organization is. You also, of course, will have external factors that impact the ISMS that you need to use, such as regulatory or compliance oversight that you need to comply with. So it's very, very important to have that well understood and planned before you start to deploy resources for high security environments on AWS. And you can see there in the background a couple of pages from our AWS Security Best Practices white paper, which we're going to talk about again more later in the session, which will give you some really good guidance on things that you need to think about in defining and designing your ISMS. So take a look at that document if you want to get some tips about the scope areas that you need to cover in this phase of your security deployment on AWS. Number 5, manage AWS accounts, IAM users, groups and roles. And we're going to talk about this over 3 slides. So your AWS account, that's the top level entity, okay, that represents your relationship with AWS. And the credentials that are assigned and associated with that root account are very powerful. They have complete authority over all of the resources that are created within that account. So authority to create new resources and also to destroy existing resources or modify them. So those root account credentials should be treated with extreme care, restricted only to the people that need to access them, protected with an MFA token, and we recommend actually that you delete the root account credentials so that API access cannot be made with root account credentials. Only users can log in using an MFA to the console as root account. And when they're logged in as root account users, they can then go on to create IAM users, multiple IAM users that have appropriate least privileged credentials to operate the areas or functions within the AWS console or the AWS API that are relevant to the roles that those users hold within your organization, or the services that those users need to execute, or the applications that they represent, and I'll explain more about what that means in a second. So it's very powerful, the root account credentials. They need to be treated with great care to prevent them being subverted or falling into the wrong hands. There's also nothing wrong, in fact we'd encourage in certain circumstances, the use of multiple AWS accounts. So you can use multiple AWS accounts to partition those root account credentials, and you might do that for a variety of different reasons that you can see represented on the slide here. Once you have multiple AWS accounts, you can reconsolidate those for billing purposes into a master account, which still allows you to take advantage of economies of scale such as volume discounting, pre-purchasing of resources such as reserved instances and other pre-purchasing methods that we offer, or resource reservation methods that we offer. And that can help you, as we've said, partition your AWS account, reducing the blast radius if one set of root account credentials are compromised, but also allowing you to have autonomy to create IAM users within individual accounts that might reflect the needs of different organizational divisions within your particular organization or entity. And you can also centralize some resources into certain IAM accounts and have others operating autonomously, which is the kind of hybrid model that's described at the bottom of this slide. So think carefully about how you should structure your AWS accounts at day one. And as I've said, there's nothing wrong with having multiple. In fact, for certain deployment scenarios, it's positively encouraged that you would have multiple accounts and consolidate those just for billing purposes. So you want to consider carefully which of those options best fits your organization. IAM users, I said we'd talk about this in more detail, so let's do that now. So IAM users, users with appropriate permissions that can create new IAM users or manage and delete existing ones. So this highly privileged IAM user can create a distinct IAM user for each individual service or application that your organization manages. Okay, so that can be a good way, once again, to partition roles using a principle of least privilege. We do strongly discourage the use of shared identities where you might have multiple users in your organization that have the same username and same credentials. That makes audit and repudiation of security incidents that much more difficult down track. So at the very least, have a different role, a different user rather, for each individual in your organization that performs an administrative role within your AWS account. Groups on IAM, they're collections of users, and those groups can themselves be provided with permissions to access resources by essentially allocating IAM policies to a particular group. And then those policies will be inherited by all the users that are members of that group. So you might have a group called administrators, you might have another group called billing admins, you might have another group called S3 admins, and you might assign specific privileges to those groups which will be inherited by those users. And of course users can be in more than one group at a time, so adding or removing permissions from a user is then as simple as adding or removing a user to or from a group. So it's akin to roles management in a traditional directory system, say an Active Directory or LDAP directory that you may already manage, and that can obviously simplify the addition and removal of roles from your users. And then lastly, you can create IAM roles that give specific permissions to other AWS resources. So a slightly abstract concept, but say I created an IAM role that had access to get pictures from a particular Amazon S3 bucket, as you can see on the example on the right of this slide. I could then assign that role to a particular EC2 instance, and that EC2 instance would automatically, or rather applications running on the EC2 instance that were developed using the AWS SDKs or the command line tools running on that instance, would automatically be provided with credentials, restricted credentials, that could access the S3 bucket that I defined within that specific IAM role. So you can use this concept of IAM roles to grant privileges to EC2 instances and to other AWS services, allowing them to manipulate other AWS services programmatically in accordance with the policies that are applied to the roles that have been allocated to them. That is a very, very powerful feature. Similarly, you can enable cross-account access, so allowing users in other people's or your other AWS accounts to access resources within your account. Again, a very, very powerful tool. In fact, many AWS partners make use of that very effectively for things like monitoring utilization of AWS resources for you or analyzing your AWS billing output. So that's commonly used in the AWS partner ecosystem, where you want to provide access to a restricted set of AWS resources in your account to a user in another account. And then lastly, on IAM, it's possible to configure and make use of identity federation, where you may use an Active Directory instance on your own site or an Active Directory instance hosted within AWS to authenticate and grant roles to users on the basis of Active Directory group membership. So that's SAML Identity Federation or ADFS Identity Federation, working in concert with your Active Directory and IAM. Once again, you can find further documentation about that on the IAM documentation site, and that enables you to use your own directory services to authenticate users and grant those users permission to work with your AWS console-based resources. So again, a very, very powerful tool which can make it simpler to manage AWS resources in conjunction with other resources that you might have within your own environment or on your own premises. So take a look at ADFS or SAML Identity Federation for that. 6. Manage OS level access to EC2 instances. So this is about logging into your EC2 instances remotely, either via SSH if you're using Linux, or using the Windows Remote Desktop Protocol, RDP. And obviously you've got to successfully authenticate yourself at the operating system level before you can access your Amazon EC2 instance for administration purposes. And we help you bootstrap this actually with a couple of different techniques. So you create something or upload something called an Amazon EC2 key pair. When you upload that key pair, if you upload it, you're only going to upload a public key and you will keep hold of the private key. If you're going to create that, we create a public-private key pair. We allow you to download the private key, which is stored on ephemeral storage for a short period of time and then destroyed immediately after you've downloaded it. So we do not hold a copy of that private key. And these private keys are used for two things. In the case of SSH, they're used to authenticate your access to Linux-based instances. So you need to have that private key in order to log on to Linux instances that make use of Amazon EC2 key pair authentication. For Windows-based instances, the private key that you hold is used to decrypt the administrator password on those Windows instances. So we are not able to decrypt that Windows password, only you hold that private key and are able to do so. So you need to have that private key in order to decrypt that password and enable you to log into your Windows instances. Again, those Windows instances make use of Amazon EC2 key pair authentication. Those public keys are provided to those instances using something called the EC2 metadata service, which is fully documented in the EC2 documentation site. If you have higher security requirements, you can disable EC2 key pair authentication and use an alternative authentication mechanism. That's important to say, but many users do make use of EC2 key pairs, and there's obviously the fact that we don't store the private keys does make that quite good practice, so you may wish to make use of that, but if you want to go beyond that, you're perfectly free to do so. Secure your data at rest and in transit. So there's a few ways and a few tools that you can use for this. The first, and maybe the most obvious, is using IAM roles for what we call resource access authorization. So you can apply a fine-grained policy to particular, for example, S3 buckets or to particular DynamoDB tables that would prevent unauthorized users from accessing data which is stored within those AWS resources. And you can see an example there of, actually this is an example of using a policy together with Amazon Cognito, which is one of our recently announced mobile services. And this particular policy is quite a sophisticated one, so it will restrict access to a particular prefix within S3 using an expansion variable, which is this particular user's Cognito identity, which is a unique identifier for each user that makes use of a particular mobile application. So in this case, we're exercising user fine-grained control over a prefix in S3 and restricting who can actually put or get objects into that particular prefix on the basis of that identity. So it's quite a sophisticated example, but it does illustrate very nicely precisely how fine-grained these controls can be. You can implement and execute extremely fine-grained resource controls by using simple IAM policies and IAM roles. So definitely take a look at that if you want to use resource access authorization within your environment. You can also, as we've said at the top of the session really, store and manage encryption keys within a cloud HSM. So this is a SafeNet device which is placed within an AWS region. We manage the appliance, the HSM appliance, but we have no access to your keys. It's in a tamper-proof device. So if somebody tampers with your cloud HSM, that will result in your keys being deleted from the device automatically. And this can provide a very secure way for you to store and a convenient way in which you can manage the strong encryption keys that you may need to store in the AWS cloud. And of course, if that doesn't meet your needs, you can still store keys on your premises and access those over a secure link such as Direct Connect with IPsec or an IPsec VPN. If you want to know more about Cloud HSM, there's lots and lots of documentation on the AWS website at the URL you can see there bottom right, awsamazon.com/cloud HSM. So check that out for more detail on that. A further area of securing data at rest and in transit is the at-rest protection that is offered by encryption, data encryption. And once again, you have several options for this. So with Amazon S3, our durable object store, you can make use of server-side encryption with either keys that we will manage on your behalf or your own encryption keys. And you can see a blog post there from the AWS blog from the 12th of June this year, where we talk about techniques that you can use for protecting, or rather using your own encryption keys together with S3's server-side encryption. So you may want to check that blog post out and make use of that particular feature if you want to place your own encryption keys per object keys inside S3 to encrypt your data. With EBS, which is our block device, our block storage that you use with Amazon EC2 instances, in this particular case you can use volume encryption provided by your operating system to encrypt your data at rest. So with Windows, that might be Windows BitLocker. With Linux, it might be dencrypt, or there's a variety of commercial volume encryption products that you can also make use of. So again, check that out if you're interested in encrypting EBS volumes at rest. And then there are also database specific crypto functions in many of the database engines that are supported on RDS, which you can find more details on the RDS product detail page about. And within EMR and DynamoDB, the supplementary best practices within the security best practices white paper, which will tell you a little bit more about how you can encrypt data within those services. Secure your operating systems and applications. So this is an important point to note. With the shared security responsibility model that we talked about at the top of the session today, you are responsible for OS hardening and updates. Now we make available Amazon Machine Images or ARMIs, which make it easy to deploy standardized operating system and application builds, and we do maintain those, so they will receive periodic security updates. You can check the ARMI listing, which is shown in the launch dialog when you start an EC2 instance, and it will tell you what the last updated date was, and you can get further details about the specifics of the images from that location as well. But once you've created an EC2 instance based on one of those Amazon maintained images, at that point forward, you're responsible for maintaining the security of that operating system environment. Because as I've said earlier when we were talking about authentication to operating system level for administration, we do not have access to EC2 instance operating environments once they're running, because we do not have the private keys from your key pairs. So you need to make sure that you are maintaining, in fact hardening and maintaining those EC2 instance environments in a way which is consistent with the security posture that you want to implement and maintain. Now you can find a lot more detail about that because it's probably beyond the scope of this webinar. You know, we could spend an hour, probably 2 hours, 3 hours talking about operating system hardening, best practices and resources that you can use for that. But rather than do that, I'm just going to point you to the AWS Security Best Practices white paper, which we'll provide you with a link to at the end of the session today, and you can find lots more information in there, including other resources that you may wish to visit to learn more about securing your OS environment. But it goes without saying that keeping up to date is a key component. Keeping up to date in terms of patching and maintenance is a key component of that process, so you must be on top of that in order to maintain the security of your environment. Securing your infrastructure more generally There's some AWS platform features that we're just going to revisit in a little more detail here that we talked about briefly at the top of the session. The first is Amazon VPC. It's a very important construct, a very important feature in terms of creating your own private clouds within the AWS cloud. It allows you to bring in your own address space, your own subnet topology, and to maintain and control your own routing table, your own network access control list, NACLs, which you might apply to those subnets to restrict or allow traffic to and from them, and also to create custom service instances such as DNS, time servers, content filtering instances and the like, which you might build inside those VPCs. So it's a very, very powerful tool that you can make use of to build a security model by using something we're going to talk about on this next slide, which is security zoning and network segmentation. So segmentation in isolating networks from one another, but also a more evolved capability of building security zones, groups of system components with similar security levels that might have common controls applied to them. You can use VPC, NACLs, security groups, host-based firewalls, threat protection layers that might control traffic flow or enforce particular policies on traffic that is traversing between zones, and applying other access control at other layers of your environment as well. So you're able to create these sophisticated multi-zone constructs by making use of the VPC together with these security zoning and network segmentation features. And I would encourage you to become familiar with everything that I just talked about there, from NACLs to flow control devices that you might want to deploy. This is where much of the power in the AWS cloud is available to you in the use of VPC together with these other constructs. Now, of course, once you've defined that topology and that security set of security controls once, you can use the AWS infrastructure together with the automated deployment tools that we provide, CloudFormation and other tools, to apply those same security controls across different AWS regions. So it's a build once, deploy many model, where that deploy many phase can be made much, much simpler and much, much quicker by using the tooling. So really would encourage you to look at VPC in conjunction with those other tools that I've mentioned, CloudFormation particularly, very powerful tool to use in this environment. Number 10, and this is the last area we're going to focus on during the session today, monitoring and alerting and logging that might enable that. So it's important to implement OS and higher level monitoring, so to make sure that the areas in your security scope in that shared model, you have good visibility and the ability to analyze logs that might be gathered from a variety of different sources within your infrastructure, from operating system and application through to some of the security services that you may run on EC2 instances, and to use those logs to give you visibility of things like invalid logical access attempts or authentication mechanisms that might be used legitimately in your environment that you may need to report upon. Once again, you can find, in a similar manner to the information that I mentioned about host-based security and hardening those host-based operating environments, you can find much more detail about best practices for logging, not just on AWS, but more generally within the security best practices white paper. So that's another area where I'd like to refer you to that white paper for further detail. There are some AWS services that are relevant here. One of them is CloudWatch Logs, where you can essentially centralize your logs, enabling you to monitor and troubleshoot your systems, consolidating log data together and using pattern-based matching and analytics to alert you to events that you may regard as critical events in your log data. And obviously these logs are then stored in highly durable, low-cost Amazon S3 storage for later access. So that is a relatively new service that you may be interested in taking a look at if you want to centralize your logging and integrate that with other AWS metrics services, the rest of the services that are operated under CloudWatch. Another service that we have is very powerful in terms of auditing and providing alerting and incident response is a service called Amazon CloudTrail. And this allows you to record AWS API calls and delivers log files of those API calls to you by depositing them in an S3 bucket. You can see the very simple setup process for this at the top left of those images on this particular slide. So just create an S3 bucket or use an existing one, put in that bucket name and your Amazon Web Services API calls will be logged into that bucket in text files. And that will contain the identity of the API caller, time, source, request parameters, and response elements. So it's a detailed log. And then you can use third-party analysis and reporting tools such as Loggly, Splunk, and actually a variety of other tools as well, to enable you to get visibility over those log files. So you might use that for security analysis, to track changes to AWS resources, to troubleshoot operational issues, identifying maybe the most recent changes that might have been made in your AWS environment, or to demonstrate compliance with internal policies or regulatory standards that you need to comply with. So again, I'd really encourage you to take a look at CloudTrail and to turn that on. It's very simple. Apart from the storage that's used to hold those log files in S3, it's actually a free service as well, and obviously S3 storage is very low cost, so you may turn that on your account even if you don't need it today, and you'll be able to populate some analysis tools with history of who's done what within your AWS account at a point in future, should you need that. And many of those third-party tools are available in the AWS marketplace as well, so you may want to test and try those tools out on a per-hour basis by using some of the licensing options that are available in the marketplace. So those are 10 best practices. Of course, there are more, and we'll show you some references in a second where you can find out more about the stuff that's over and above what we've talked about during that quite lengthy discussion of best practices during today's webinar. Last couple of things we're going to focus on: verifying AWS security. So we're conscious that many customers need to have compliance statements and need to have visibility of AWS's compliance posture. So we, for example, hold PCI DSS Level 1 accreditation for customers that want to run payment processing or store and transmit credit card information within the AWS cloud. We hold a accreditation that covers our scope area within that shared security responsibility model that we talked about at the top of the session. Also, we operate our scope under an ISO 27001 compliant security management system. So once again, if you need to do that, you can be secure in the knowledge that our scope areas are already covered, and we already have audit reports that demonstrate that. And we also comply with many other government and industry compliance requirements. And if you want to know more about that, we have a large documentation set at the Compliance Center available on the AWS website at awsamazon.com/compliance. So go there and check that out. If you need more on compliance, we can also, for example, under NDA, share additional information about our compliance stance, including audit reports that have been undertaken on AWS services that we can share with you under a non-disclosure agreement. So if you do need that, once again, please get in touch with us. In fact, you can submit a question through the webinar platform and we'll follow up with you. Or of course, you can contact us via your account manager or the contact us form on our website, and we can follow up with you and provide you with NDA documentation that will enable you to access those compliance statements should you need to do so. Other resources that you may wish to use if you want to learn more about security at AWS. Here are some useful links. So the Amazon Web Services Security Center, the Amazon Web Services Compliance Center, and comprehensive product documentation for IAM and VPC, which have been quite big focus areas within this session today. The other products that we've mentioned, services that we've mentioned during today's session, all have security documentation associated with them in their own documentation sets. And in general terms, if you go to awsamazon.com/service name, so RDS/DynamoDB/EC2, you'll find a product detail page which has a significant amount of documentation about the services, together with links off to a documentation site, which itself will include comprehensive security documentation such as IAM resource restrictions that might apply to this particular service, how this service integrates with VPC, etc. So you can also look at product-specific AWS pages to find out more about specific products. But those are 4 key links that everybody that's attending the webinar today should really follow up if they have an interest in AWS security and running secure services on AWS. We also have a blog, which is great for real-time content, best practices, detailed examples of particular security practices on AWS, and of course new feature releases. And you can see some examples of recent posts here. So recently posted on for example, how Amazon Cognito, which we've mentioned briefly today, interworks with existing Web Identity Federation, or how you might share AWS CloudTrail log files between different accounts using IAM cross-account roles, for example. So there's lots of good stuff here. If you're interested in security best practices and maybe in developing your knowledge of security on AWS, it would be a good destination for you to check out, blogs.aws.amazon.com/security. And maybe the anchor content that we've been discussing today the AWS Security White Paper, the AWS Security Best Practices White Paper, and the AWS Risk and Compliance White Paper. Once again, I'd say that these are essential reading for anybody that is interested in building high security environments using the AWS cloud. You should make use of these resources. Not only do they contain great insight into how you can build on AWS in a secure way, a more secure way, but they also contain great insight into industry best practices and other resources that you might find useful. We already talked about OS hardening resources. We already talked about guidance for developing an information security management system, and we've already talked about guidance for logging, which is provided in the Security Best Practices paper. You may find that's applicable to your existing environments as well as to what you do on AWS. So I really would advise you to take a look at these resources and make liberal use of them if you think that will help you. They're really good resources to use. If you're interested in further developing your AWS expertise, you may be interested in Amazon Web Services training and certification offerings, and you can find comprehensive details on those at the URLs you can see on the slide. Visit aws.amazon.com/training and actually find links on there to these other resources. That will explain to you how you can become an AWS certified architect or an AWS certified architecture professional, the higher level of certification that we're currently offering. And both of those certifications include a healthy dose of security on AWS. I hold both of them, and they both include security in both the training curriculum and in the certification exams. So if you want to prove your AWS security expertise, then those two exams are a great place to go. We also have something for systems operations personnel and something for developers as well. So check out awsamazon.com/training for those. I think you'll find some useful resources there. And one event that we have coming up here in London, if you happen to be in the UK, on October the 21st, we're going to hold our second AWS Enterprise Summit of the year here in London, in Bishopsgate in the city, in an events venue there. And we'll be talking there, or rather, we will be talking together with AWS partners and customers about how customers, enterprise customers, have built real-world implementations with AWS and undertaken significant application migrations and new application deployments on AWS, including managing their own security and compliance needs. So if you want to come along to an in-person event here in London and learn more about enterprise use of AWS, this might be a really good event for you. October 21st here in the City of London. You can find the registration page at the short link that you can see on the page here. I'd really like to encourage you to join us at that event. We'd love to see you there. I'll be there in person, so if you've got any difficult questions from today's webinar, you can follow those up with me in person at the event. And of course, if you have any other questions that you'd like to ask during the session today, please submit those now using the Q&A panel that you can see in the webinar interface. We'd love to take your questions, answer a few of them during the session today, and of course those that we haven't answered during the session today we will get back to you on. And if you'd like to stay up to date with AWS generally, then please find us on social media at these links. You can find us on Twitter at AWS Cloud, which is all about AWS global news and service announcements. Find us here in the UK and Ireland at AWS_UKI, where you can stay up to date, for example, with our Enterprise Summit program of events, roadshows that we'll be running around the UK next year, and other more developer and professional focused events that we'll be running throughout the course of the next year here in the UK and Ireland, as well as with the webinar program that we continue to run throughout this year and next. So AWS_UKI for that. We'd love to see you following us there. And you can find me on Twitter at Ian M as well. If you've got questions from the session or you want to tweet me feedback, I'm very happy to take that on Twitter. We do a lot of events that are outside of the AWS events program, developer events, user groups around the country, and I always tweet about those when I'm going to be doing those events. So if you want to meet us in person and talk to us at one of those events, then find me on Twitter and keep up to date with what I'm up to. Okay, so that concludes all we have for you today in terms of content. We've got a few minutes, so we're going to take a look at a few questions now and hopefully answer a few questions. Thanks for your participation today. Please don't forget to rate the webinar using the ratings panel, and please don't forget to grab the materials if you wish to do so, and let us have any qualitative feedback that you have in the Q&A. So let's turn to a few